Hi there. So this video series is going to be covering the process of cutting what looks like a pretty complicated helical screw, but in actual matter of fact, it's a pretty quick and easy process. Since we've covered most of the core operations in the more prismatic 4D video series that I covered, we generally know what it is that we're doing with regards to this. There's nothing particularly outlandish in any of it. We've already dealt with things like rotary transformations, and most of the operations beyond that are slight modifications of operations that we've dealt with historically anyway. So let's take a look at roughing this out, shall we? And you'll see that this is basically set up as an already partially machined part. So I'm assuming that this has come out of a turning center somewhere, and we've been tasked with milling out these vanes here to make it into a proper helical screw. So what are we going to do? Well, we'll take a look at the roughing options that we've got. So under the operations menu, we've got our standard 3D entry roughing options. We do have things like roughing water lines as well. But in this instance, I'm going to suggest that rotary roughing is probably going to be our best bet, because in truth, the shape looks more complicated than it actually is. It's not that difficult for a CAM program to deal with. So if we click on rotary roughing now, and quite conveniently, it's already jumped to the tool that we were intending to use. The things that we need to define now, really, are, again, not super convoluted. We're going to have a look in job assignment. Now, the top level and bottom level are relative to the surface of the cylinder. So that's our top level, and this will be our bottom level. The main thing that we need to look at is the strategy approach. So we are going to go with a circular trajectory form, and we're going to define the minimum and maximum axial positions. So if we click on these, go to millimeters, I'm going to grab this plane here, and I'm going to move it up to the edge there, which is now at 11 millimeters. That's because we don't need to do anything to this part, and we won't need to do anything to this section either. So under maximum axial position, we'll grab millimeters again, and we will go, I don't know why it's jumped to 10 millimeters there, it's a little bit crazy. We'll drag that one, we'll select that, and we'll drag it across to here, which is 95 millimeters. And that should realistically cover the range of access that we need. So the next thing that we're going to do is, because this is a roughing pass, we are going to go to parameters, and we're going to define the amount of remaining stock, because obviously we don't want to take this all the way down to the bottom. So I'm going to set 0.5 millimeters radial, and yeah, 0.5 millimeters axial, why not? I'm also going to loosen up the tolerance a little bit to 0.1 millimeter, because it just makes it that little bit quicker and easier to calculate. So at this point, we have covered most of what we need to. I think we can probably get away with generating the toolpath. So let's take a look at what it produces. And as we can see here, there's not really much to see. It doesn't look like there's an awful lot going on, which isn't strictly accurate. There is, but we haven't defined step down or anything, and the assertion is usually that it's going to go at 100% straight off the bat, which is not quite accurate. So let's go to strategy, and the depth step is currently set at 100%, so I'm going to suggest we put that down to 20%, and then regenerate the toolpath, because not only will that make things a little bit more obvious as to what's going on, but it should actually give us a slightly better finish as well. So we've done that. I'm generally happy with how that looks. I think we should probably simulate matters now to see how things come up and to make sure there's no obvious crashes. So if we jump over to simulation, we're going to slow this down a little bit to take a look at how it comes up, and let's click run. So far it's realistically behaving exactly as we'd expect. There's nothing overly drastic going on there. We can see there's a little bit of an offset from each of these vanes, which is kind of what we want really. So I'm content to say we can probably speed that up and see how it looks. So let's let that run through. And as we can see, it's going across the entire part in a circular manner, maintaining the same level of cut each time. Which again is good. It gives you the chance to slam the E-stop button if anything's going horribly wrong without having wrecked the entire part. Because let's be honest, we've all been there. It's that horrible, scary moment when you think everything's right and then suddenly reality proves otherwise. Anyway, as we can see here, we're actually getting quite a nice scalloped finish on this. You know, for a creative piece, that'd actually be quite pretty. But realistically, for what we need, it's largely irrelevant. However, as we can see, this is now roughing down quite nicely and bringing us fairly close to the shape that we want this to be finalised as. So that does mean that our subsequent passes are not going to be particularly heavyweight cuts, nor is there going to be a lot of complicated planning work required for them. So yeah, I'm quite happy with that. We can take a quick look at the verify compare. We can see that we're still well outside the plus minus 0.2 territory here, but if we bump that up to +1 and put this to plus 0.5, we can see that generally we're looking pretty close to what it is that we actually need out of this. Excuse me. So with that, I am content to let this be and to bring this to our next video in the series, which is going to cover the surfaces of these particular larger areas of the helix of this screw. So I will see you in the next video.